Factoring polynomials by GCF. Factoring polynomials is the process of finding the common factors and dividing them out to represent an expression in a different format. You do not change the values of the expression. Now, in this video, you'll also have to factor variables. So, let's start with an example. 8x plus 12. If we want to factor this expression, first we need to know what a factor is. So if you don't know at this point what a factor is, please go back and watch the video, What is a Factor? Or it may just be titled Factors. So if you have any problems, please go and watch that video. So what we're going to do is we're going to look for the GCF or the HCF for both numbers. And in this case, they both have a GCF or HCF of 4. So we will divide both of the values here by 4, and we're going to place the 4 in the front. So we're going to put a 4 out front here. And you can't just throw it away, or else you'll change the value of this expression. So 4 comes out, and what's left is 2x plus 3. That is factoring by a GCF. And you can check your work by distributing back. So if I distributed the 4 back into this problem, 4 times 2x would give me 8x, and 4 times 3 would give me 12. Now, to factor with variables, let's say you have 3x squared plus 27x. 27x. Looking for the GCF of both numbers, if I were just looking at the numbers, the GCF for the number part is 3, so I can bring the 3 out front. Okay. Now, notice both of these x, the variables, both of them have a common x. For this term, we have x times x, and for this term, we just have x. So something that they have in common is a single x. So I know that I can factor out or divide it out from both of those terms. So now I have a 3 and an x in the front. Now, if I took the x out, I would only have one x remaining here. And of course, if the 3 was divided out, there would just be a number or a value of 1 there. You don't have to write the 1, but it's okay if you do. So I only have a single x left here, plus 3 times 9 would generate the 27, and the x has been taken out, so I don't have any x's left here. Now I have factored with both numbers and variables. And again, to check your work, you can distribute back in. 3x times x would generate 3x squared, and 3x times 9 would give me 27. Now, you may have more terms. It might not just be a binomial or a 2-term polynomial. So if you have more terms, you do the same thing. For example, if we have 4x squared plus 6x minus 12. If you look across each of these values and find the GCF or the HCF, you'll notice that it is 2, so we can bring 2 out. And in this case, when you look all the way across, even though this term has an x squared and this one has an x, this one has no x's, so we cannot say that there is a common factor all the way across. It has to be in every term. So in this case, I cannot take a variable out. So once I've taken out the 2, I am left with 2x squared plus 3x minus 6. And I can check by distributing the 2 back in. 2 times 2x squared is 4x squared. 2 times 3x is 6x. And 2 times negative 6 is 12. Thank you.